Hello everyone, myself Pradeep Paul from Sri Venkateswara College of Engineering, Bangalore. I am here to present a topic on application of numerical method. Contents Introduction Application of numerical methods. Importance in applications of numerical method. Numerical method in everyday life. Common perspectives of numerical method. Types of numerical method. Advantages and disadvantages of numerical method. Uses of numerical method and conclusion. Introduction: Advanced numerical methods are essential in making numerical weather prediction feasible. Computing the trajectory of a spacecraft requires the accurate numerical solution of a system of ordinary differential equation. Car companies can improve the crash safety for their vehicles by using computer simulation of car crashes. Such simulation essentially consists of solving partial differential equation numerically. Hedge funds, private investment funds, use tools from all fields of numerical analysis to attempt calculate the value of stocks and derivatives more precisely than other market participants. Airlines use sophisticated optimization algorithms to decide ticket prices, airplanes and cruise assignments, and fuel needs. Historical such algorithms were developed within overlapping field of operation research. Application of numerical method. Numerical method is a mathematical tool designed to solve numerical problem. The implementation of numerical method with an appropriate convergence check in a programming language is called a numerical algorithm. Example include Gaussian elimination, the QR factorization method for solving system of linear equation, and the simplex method of linear programming. In practice, finite precious is used and the result is an approximation of the true solution assuming stability. The next slide is importance of numerical method. Mathematical models are a central pieces of science and engineering. Some models have closed form solution, therefore they can be solved analytically. Many models cannot be solved analytically or the analytic solution is too costly to be partial. All models can be solved computationally and the result may not be exact answer but it can be useful. Numerical method provide a way to solve problems quickly and easily compared to analytical solutions. Numerical methods in every real life. There are four types: estimation ocean current, modeling of airflow over airplane bodies. Third one, electromagnetics. Fourth one, modeling combustion flow in a coal power plant. Why study numerical methods? Solve problems that are difficult or impossible to solve analytically. Large system of equation, nonlinear differential equation, complicated geometries fit mathematical model to data. They form the guts of most analysis software in engineering and science. Finite element analysis, structure, mechanical design, composition, fluid dynamic, PSPs, electric circuit modeling. The next slide is types of numerical method. There are many types of numerical methods. Of them, the most commonly used one may be as under. Methods of finding the roots of an equation. They include bisection method. The bisection method is an approximation method to find the roots of the given equation by repeatedly dividing the interval. This method will divide the interval until the resulting interval is found, which is extremely small. The second one is regular falsy method. The regular falsy method is the oldest method of finding the approximate numerical value of a real root of an equation f of x is equals to 0. This method is also known as the method of false position. The third one is secant method. Secant method is also a recursive method for finding the root for the polynomials by successive approximation. It is similar to the regular falsy method, but here we don't need to check f of x and f of x1 and f of x2 lesser than 0 again and again after every approximation. Fourth one is Newton method. Newton method also known as the Newton-Raphson method, named after Isaac Newton and Joseph Raphson, is a root-finding algorithm which produces successively better approximation to the roots of a real valued function. Next one is fixed point iteration method. The fixed point iteration method uses the concept of a fixed point in a repeated manner to compute the solution of the given equation. A fixed point is a point in the domain of a function g such that g of x is equals to x. In the fixed point iteration method, the given function is algebraically converted in the form of g of x is equals to x. Common perspectives of numerical method. When presented with a problem that cannot be solved directly, they try to replace it with a nearby problem that can be solved more easily. Examples are the use of interpolation in developing numerical integration method and root finding method. Numerical methods are commonly involved in an iteration method due to the degree of accuracy involved. This is because iteration reduces the approximation errors which may occur in numerical problem. Numerical methods provide a way to solve problem quickly and easily compared to analytical solution. Whether the goal is integration or solution of complex different equation, they, there are many tools available to reduce the what can be sometimes quite difficult analytically math to simple algebraic. Advantages of numerical method. Numerical approach gets the advantage of the repetitive nature of computer to solve complex problems that require lots of iteration. Numerical analysis applications are disturbed among different areas such as compositional fluid dynamic analysis, structural analysis, kinematic analysis, and even economic analysis. Numerical approach enables solution for a complex problem with a great number, but of every simple operation. The major advantage of numerical method over analytical method is they are easily implementable with modern day computer and provide solution in quick time as compared to analytical method. Disadvantages of numerical method. Numerical data from people does not define their feeling towards certain topics. Results are short and limited. Generic questions from researchers can lead to structural bases. Limitation for each numerical methodology. Spectral age, discontinuous, finite difference heights, mishaped domains. Finite volume imposes accuracy but might ignore physicality. Finite elements are hard to generalize, etc. End correction are not simple like trapezoid rule. In fact, the one-third rule does not allow a simple endpoint correction using the first derivative. It requires the third derivative. Weak against data patterns like tail skinny peaks. Trapezoid more efficiency in jobs. Uses of numerical method. Numerical method provides an approximation that is generally good enough. It is useful in all fields of engineering and physical science and growing in utility in the life science and the arts. Movement of planets, stars and galaxies, investment portfolio management, quantitative physiology, simulation of living cells, airline ticket picking, crew scheduling and food planning. Let us conclude. The advancement of numerical analysis and its application over the past decades have provided an incredible powerful method for researchers to study. The use of such approaches is still not common nonetheless, and the documentation of bad practice is all too often present when applied. Probably the reason for this is a lack of knowledge and direction as to reasonable use of such approaches of study, in particular from codes of practice. It is clear that some sort of initiative is required to improve good exercise and to allow the full potential of analytical tool to be realized from both a protective and economic perspective. The numerical common sense to analyze the major benefits of and applications of numerical analysis over typical methodologies and addressing whether or not it can replace the conventional analytical tool in the design process. Existing literature is used widely to demonstrate the consideration for the use of numerical analysis. Thank you for watching my video. Please like, share and subscribe.